For example 6, it says, are the polygons similar? If they are, write a similarity statement and give the scale factor. So first of all, we need to check angles, and then we need to check our corresponding sides. So let's just check and see, okay, is J congruent to T? Yes. K to U? Yes. L to V? Yes. M to W? Yes. Okay, so we can check that off, that angles are congruent. Secondly, we need to figure out our sides. So MJ would compare to WT. So 6 over 6. Then we would have JK to TU, so 12 over 6. And then KL to UV, which would be 24 over 16. And then lastly, the 24 over 14. So if I were to reduce each one of these, like here I would get 1 over 1. That means that all of these should be 1 over 1 in order to be similar. And as we can see, it's not. This would be like 2 over 1. Then we would have 3 over 2. And if we reduce the last one, we would have 12 over 7. So these are not proportional sides here. They're not the same. So are this polygon similar? No. If they are, write a similarity statement and give the scale factor. Well, we can't give the scale factor. We can't write a similarity statement because the answer was no. So moving on to B, we check the angles here. So A should be congruent to D, and it is. B should be congruent to E, yes. And C should be congruent to F, which it is. So we can write angles are congruent. Alright, so now let's compare the sides. So AC, which is 8, would be DF, so 10. And then we would compare, let's go AB to DE, so 12 over 15. And then CB over FE. Okay, so if I reduce these, we would get 8 tenths, we reduce to 4 fifths. 12 fifteenths can reduce by 3, so that would be 4 fifths. And 16 twentieths, you would divide by 4, we get 4 fifths as well. So this is proportional. So yes, absolutely. These are similar polygons because the angles are congruent, the sides are proportional. And the scale factor is 4 fifths. And the similarity statement would be triangle ABC is similar to triangle DEF. Okay, in example 7, for this part, it says using similar polygons, you basically want to use the scale factor given to you and find the value of x, okay? So for part A, if the figures below are similar with a scale factor of 2 to 3, find the value of x. So since 2 is smaller, I'm going to go with the smallest figure first. So I would say, okay, 2 over 3 equals 42 over x. And then I would just use cross products to solve that. So that would be 2x equals 3 times 42, which is 126. To get the x by itself, I'm going to divide by 2 and get 63. For part B, again, my scale factor is 6 over 5. And this time, since the bigger number was first, I need to use the bigger figure or triangle. So I'm going to go with this one here, which is the x. And that compares to 28. So again, I need to cross multiply. Divide by 5, and we get 33.6. Okay. In letter C, so to find the value of x, we need to set up proportions. So for example, like I know that I'm given AB is 25. and AB compares to DE, which is X. Then I have BC, which is 20, and BC compares to EF, and that is 28. And so then I could go ahead and cross multiply. 25 times 28 is 700. Divide by 20, we get 35. In letter D, very similar. I am kind of running long on this video, so I'm going to quickly set this up. So I would say X over 32, and I would use this to help me figure out what side lengths compare to each other. Okay. And then lastly, you just have a little bit of algebra in there. So it looks like our number got cut off over here, and this length is 32. So we would say 32 over x plus 3. Again, I would look at GA and know that's xk. Okay? And then 36 over x plus 6, we would need to distribute. If I subtract 32, we get 4x. If I subtract 108, we get 84. And we divide, we get 21. That was very fast-paced, but at this point we should know how to solve an equation.